Astronomers confirm a second Troijan asteroid for Earth. That's already a few days old. I will put a link below to the intro. If asteroid 22XL5, the second known Troijan asteroid for Earth, left a visible trace of its motion in our sky, over time we'd see its motion as a big oval. This magnified view is from Cerro Pachón in Chile, where astronomers confirmed the asteroid 2020XL5 orbits at L4, a Lagrange point in the Earth-Sun system, where objects tend to stay fixed relative to the Earth and Sun. The arrows show the direction of the asteroid's motion in orbit. The view is only imagined because we can't see Earth-Troijan asteroids except in very large telescopes. It's exceedingly dim at magnitude 22. A second Troijan asteroid for Earth. Remember the excitement in late January when the James Webb Telescope reached Lagrange point 2 or L2? That's a gravitationally stable point in the Earth-Sun system where a spacecraft or a natural object can orbit the Sun while maintaining its position relative to the Sun and Earth. There are 5 Lagrange points. 2 of these points, L4 and L5, are on Earth's orbit around the Sun. Asteroids located at the Earth-leading Lagrange point L4 and the Earth-trailing Lagrange point L5 are known to astronomers as Troijan asteroids or Earth Trojans. Astronomers already knew Earth had one Troijan. Now we know it has 2, with the second announced on February 1st, 2022. This new Earth Troijan has been labeled 2020XL5. Discovering the Troijan asteroid. Astronomers first discovered this new object on December 12th, 2020, using the Pan-STARRS 1 survey telescope in Hawaii. Without much data to go, scientists couldn't say if its orbit was simply intersecting ours or if it was a true Troijan asteroid. The first Troijan asteroids, and still our solar's largest known population of Troijan asteroids, lead or follow Jupiter in orbit. Jupiter has more than 7,000 Jupiter Trojans. That makes sense because Jupiter is our solar system's most massive planet. Its gravity, or electric field, would naturally pull more asteroids toward itself, for example, Earth's much weaker gravity. That's why until now Earth had only one known Troijan asteroid. This was a really difficult sentence. 2020XL5 is nearly 3 times larger than Earth's other known Troijan. Here you can see the L points. And then here, and of course on the other side. More Troijan asteroids. We mentioned the giant planet Jupiter has the largest population of Troijan asteroids in our solar system. More than 7,000 are catalogued, but if astronomers could find them all, we'd probably learn that Jupiter is home to more than 1 million Trojans larger than a half a mile, 1 kilometer in diameter. Meanwhile, Neptune has 28 identified Trojans. Uranus is known to have 2, little. Mars, 1 step outward from Earth, has 9 known Trojans. Venus has only 1 temporary Troijan asteroid that we know so far. The newly found Earth Troijan is more than a half mile in size. Contrast its size to the first known Troijan, labeled 2010 TK7, is less than 1,300 feet, 400 meters across. After finding the asteroid in 2020, a scientist searched through old data from the Dark Energy Survey from 2012 to 2019 to find more images But the new results from SOAR are the ones that clinch the identification. The scientists say 2020 XL5 is a C-type asteroid. It's the most common type of asteroid, which is dark and carbon-rich. It's not a snowball. Lead author Tony Santano Ross of the University of Alicante in the Institute of Cosmos Science of the University of Barcelona said in a statement. Source data allowed us to make the first photometric analysis of the object, revealing that 2020 XL5 is likely a C-type asteroid with a size larger than 1 kilometer. In a stable orbit for now. Asteroid 2020 XL5 is in a stable orbit at the moment at the Earth's Sun Lagrange point 4. It orbits the Sun at the same distance as Earth, leading Earth in our 365-day orbit around the Sun. The other known Troijan asteroid 2010 TK7 also orbits at the Earth-leading Lagrange point 4 or L4. Studies by astronomers show, however, that 2020 XL5 will only be in this stable orbit for a number of thousand years. L4 is relatively stable gravitationally, but it's not infinitely stable. The astronomers who studied it said that perturbations, minor gravitational pulls from objects other than the Earth and Sun, will ultimately fling the little asteroid out of L4. That'll happen in about 4,000 years. Cut loose from L4 and from the bonds of Earth's gravity, it will then continue on its way to wander through the space of our solar system like the millions of other large and small bodies that reside in our Sun's family. Yeah. You know how Venus passed between us and the Sun last month in February 2022 is racing ahead of Earth in its smaller orbit? And if you looked, you know how we see Venus very near to the sunrise in the horizon now. Earth Trojans at L4 are similar to Venus in that they are moving ahead of us in orbit and reside near the sunrise. You can read the rest of that I read now quite much. But anyway, Trojans, asteroids, carbon rich asteroids, the most common asteroids. Thanks. Bye.